Alright, so we have started with radical functions. Now, a radical is simply a root. That's what we call radical. So when you're talking about functions, you are talking of functions of x that are in a root. For example, you have got, let's say y is equal to the square root of x. This is a radical function. Now what we are going to do is, for all functions that you discuss, you need to be able to sketch, find the domain and the range, solve inequalities, solve equations. Those are the things that you need to know for every function that you discuss. Whether quadratic functions, rational functions, radical functions, modulus functions, trigonometric functions, logarithmic functions, exponential, you need to sketch, state the domain, state the range, solve inequalities, and solve equalities or equations. So what I'm going to do is I'm going to start with sketching. So I'll start with this basic one which you're able to see here. Y is equal to the square root of x. So if you want to use a high school way, you can draw a comma simple table showing x values and y values. So you say when x is 0, what should be the value for y? Put 0 here. So y is going to also be 0 because you know that the square root of 0 is 0. What of when x is 1? Put 1 here. The square root of 1 is 1, meaning that y also be 1. Since I'm using a root, I'm going to just be working with perfect squares. The next perfect square after 1 is a 4. So when x is 4, I'll put here. You are going to see that y is going to be 2. Now take note that you cannot use an x value which is negative. In other words, the domain of a radical function, you get what is inside the root. It should always be greater than or equal to 0. So this is the domain of this radical function. Whatsoever is in the root, they should always be greater than or equal to 0. So to sketch this function, how it is going to go, if you want, you can use the values that you have found. This function will always go like this. It starts at 0, 0. It continues to go like that. Okay? So this is a radical function. Y is equal to square root of x. It cannot go to negative numbers. So you can't have a negative value of x being used. Because of that, you also can't have a negative value of y. So we are saying for this function, the domain, so say d with a subscript f, domain of this function is what? X is greater than or equal to 0. That's a domain. Or we can put it in set builder notation, or we can put it in interval notation. We can say it is from 0 up to infinity. We are including 0, but we know that we never include infinity in these sets. So that is how we are able to write it. Or I can say domain of this function is equal to, so I'm going to say x is a member of real numbers such that x is greater than or equal to 0. I can also put, whether you write this, you write this, you write this, it's still the same thing. So that's a domain. Those are the x values which are accepted for this function. Now what of the range of this function? Well, you can clearly see that the range, the only y values you can have is starting from 0 going where? Going up. So meaning that the range y is greater than or equal to 0. That's the range of this function. So that is how you're able to determine the domain and the range for such a function. Well, just the same function that you're able to see here, let's alter it a bit. Let me attach a negative outside. How does it change when I attach a negative outside? So you see that for this function, you've attached a negative on the function itself, meaning that the function is going to be going towards negative values of y. But you can see that x itself is what? Positive, meaning that the function is going to be going towards positive values of x. So positive values of x is this side, but towards negative values of y, meaning down. So how is this function going to go? This function is going to be going like that. That's how it changes. It was supposed to be going up, but it is now going down like that. Why? Because we've attached a negative. Meaning that for this function, the domain of this function, the smallest x value is still 0. The biggest x value still be infinity, like it is going towards infinity. You can see it's going in this direction. And then the range of this function, you can see now it has changed. The smallest y value is going to be down because the function is going down, right? Even you can see that the function is going to be going like that. So the smallest y value is going to be negative infinity. And then the biggest y value is 0 here. So you always start with a smaller value and then you go to the bigger value. You are including 0, but you don't include negative infinity. This is the range of this function. Okay, so what I'm going to do is, for now, let me pause a bit and see if it is okay. Do we have anyone with a question? Anyone with a question? Are we good so far? At least if there's no question, I need to hear if we are good. Are we good so far, or there's a question?
We are good so far.
All right. Now the next one, let's say we have got y is equal to square root. Now inside, let's have negative x. How can we sketch this? So inside you have got a negative. So this function still the same, is still a radical. Okay, so x values there and y values there. Now you can see that x inside is negative, meaning that this function is going to be going towards the negative values of x. But you can see that there's no negative there, meaning that a function itself is positive. Okay, since the function is positive, it will be going towards positive values of y. So this function is going to be going up. So how are you able to see? So it's going to be going towards negative values of x, positive values of y. So this function is going to be going like that. Please just take note that it goes more like on the, it always follow the x-axis. Like it will always follow the x-axis. Okay, it will always follow the x-axis. So you can't draw it like this. That would be a quadratic function you are drawing. Okay, it doesn't follow the y-axis, it follows the x-axis. Excuse me. So what changes when it becomes y is equal to negative square root of negative x. So let's see how this function is going to change. So for the one that I'm just from drawing, the domain, the smallest x value is negative infinity, this side where it's going. The biggest x value is 0. So the domain is from negative infinity to 0. But the range is from 0 to positive infinity, because the highest y value you are going up, the smallest is 0. So for the function, you can see that there is a negative, meaning that it will be going towards negative values of y. And then x is also negative, to be going towards negative values of x. Negative values of x, negative values of y. So for this function, it is going to be in the fourth quadrant like that. So this is how the function is going to be going. Okay. So that is how you get to sketch radical function. So whatsoever that you are going to add to this, it will not necessarily not transform change anything. It will just be a transformation that you already know. Let's say you have got y is equal to the square root of, let's say, 4 minus x. You want to sketch this one. So what you are going to do is just get what is inside there, equate it to 0. Just that. Okay, get what is inside, equate it to 0. You are going to find, if you say 4 minus x is equal to 0, you are going to find that x is equal to positive 4. So the function is going to start at positive 4 here. Look at x. X is negative, meaning that the function is be going towards the negative values of x. Sorry, negative values of x is this direction. And then the function itself is positive, meaning that the function is going to be going towards the positive values of y, up. So this function will start from here and then it will be going like this. So if this one came for you to sketch, then you need to find this point where it cuts the y-axis. How do you find that one? X should be equal to 0. You know that the y-intercept happens when x is 0, so that is going to be a 2. Like you put 0 here, you are going to remain square root of 4, which is going to give you 2. You could have determined also the domain by just looking at what is inside. You know that for a radical function, 4 minus x should always be greater than or equal to 0. I'm going to take for the other side, so negative x is going to be greater than or equal to negative 4. Divide both by a negative. When you divide by a negative for a radical function, the sign is going to change, positive 4, meaning that the domain is all values of x less than or equal to 4. That is what we are able to see here, like use 4 and less. We can also write that from negative infinity up to 4, like that. That's the domain. The range for this one, you can see that the smallest y value still is 0. And then the highest y value are going up is still positive infinity. So it will be 0 comma infinity. As long as you've not added the constant outside the root, the range will always be between 0 and infinity and negative infinity and 0, like that, as long as there is no constant added to this function. So that is how the function is going to be able to shift. So let's say we add a constant. We have got y is equal to, let's say, 2 minus square root of x. Then now I will be able to sketch this function. So to be able to sketch it, this is the y-axis, there the x-axis. Okay, so for this one we can see that we've not changed x. We've not added anything to x, meaning that x value we're going to start with is at 0. And then now this constant here changes the y value, meaning that for the y value we're going to change, it goes at 2. So the function is going to now start at 0 comma 2, which is here. Okay, so just this constant you've added, that's what shifts the graph. Now you can see that the function is negative, meaning that it will be going towards negative values of what? Y. But x is positive, meaning that it will be going towards positive values of x. Okay, so the function is going to be going like this. So also for this one, we need to find this value here where the function cuts the x-axis. And we know that where it cuts the x-axis, y is equal to 0. So we're going to put 0 here. So we are going to say 0 is equal to 2 minus square root of x. Take square root of x the other side, it becomes positive, and that will be equal to 2. To find x, square both sides. So I'm going to find that x is equal to 4. So this is the point where it cuts the x-axis. It is at x is equal to 4. Basically, that is how you sketch. Now, what if you join both? You have got a value that are shifted in the y and in the x. Let's say you have got y is equal to, let's say, negative 4 minus, let me say, plus square root of, let me say, 9 minus x. How can we sketch this one? So friends, there's nothing that is any complex about these functions as long as you follow what I've just said. Radical functions are going to be so easy to sketch for you. Okay, the x value here, the y value. So equate what is inside here to 0. We're going to find that x is positive 9. So the function is starting at positive 9. Okay, and then let me actually, just to make it nice, okay, it's fine with a positive here. And then, so when we equate it to 0, we are going to find 9, and then this constant, that's a negative 4, put there. So the function has been shifted. It is now starting at 9 comma negative 4 here. Okay, now if you see x is negative, meaning that it will be going towards negative values of x, and then the function is positive, meaning that it will be going up. So this function now, for this one, this is where people get it wrong now. For this function, since it's supposed to be going up and towards the negative values of x, it can either cut both x-axis and the y-axis, or it can only cut the x-axis below and then cut the y-axis, or it can pass through the center. So if you miss it, instead of you drawing it on top, you draw it below, you get it wrong. Or if you are supposed to draw it on the middle, you draw it somewhere else, you get it wrong. So how do you determine where it's going to pass? Just get any intercept, whether the x-intercept or the y-intercept, just that. So I think x-intercept to be, y-intercept to be is easy when x is equal to 0. Just equate, you can equate x to 0 if you want, or y to 0, but it is easier to equate x to 0. So come and put 0 here. So we're going to remain with square root of 9. So we're going to find that y is going to be equal to negative 4 plus square root of 9. And that is negative 4 plus 3. And that is going to give you negative 1. So I saying that when x is 0, y is what? Negative 1. So the function is coming to pass here at negative 1. So you can easily determine that the function is supposed to pass below. Okay, so the function is going to go like this. Cut and then continue going like that. Continue going to continue going like that. So this is how the function is supposed to appear. So it would have also passed on top here, but not just for this one. Maybe if we had a 16 here, it would have passed on the middle if we had a 16 on the middle here, because square root of 16 is 4, negative 4 plus 4 is 0. But if we had a 25 here, it would have passed on top, because square root of 25 is a 5 and 5 minus 4 is a positive 1, so y would have given us a positive value. So for this function, the domain of this function, the domain, the accepted x values, you can see that the smallest please always start with the smallest x value we can have is negative infinity. The biggest x value we can have is positive 9. So write it like that. And then the range for this function, the smallest y value you can have is a negative 4. The biggest y value you can have, we are going up. So that means it's positive infinity. So this is how it's going to be. So this is how you get to sketch radical functions. That's how you sketch them. Do you have any question? Any question? Yes, Paxin.
Yes, sir. What if where there is negative 4, there was negative 4x?
There was negative 4x.
Yes.
So that will no longer be just a radical function, but it will be another function. It becomes more like a polynomial. Okay? Is that okay?
Somehow.
Okay, these numbers which are supposed to be added are supposed to be constants. So they are not supposed to be other numbers, it's supposed to be constants. Alright. So let's say now we have got y is equal to the square root of 4 minus x squared. How can we sketch this one? First thing first, I'm going to get what is inside, I equate it to 0. So 4 minus x squared is equal to 0. Take the x squared, the other side becomes positive x squared, and that will be equal to 4. So find that x is going to be equal to positive 2, or x is going to be equal to negative 2. Now for a function like this one, I'm going to get these two values of x that I have found, negative 2 and positive 2. I'll put them there. Okay. And then I'm going to write the function itself, that is 4 minus x squared. So what happens if I get a value of x smaller than negative 2? I put in the function. For example, negative 3. Let's put negative 3 here. We know that negative 3 squared is positive 9. 4 minus 9 is negative. So this is going to be negative, right? And then if we get a number between negative 2 and positive 2, like a 0, we put here 4 minus 0 squared is going to be 4. That's positive. If we get anything above 2, we put here like a 3. 4 minus 3 squared is to still give us negative. And you know that for radical functions, friends, it is always supposed to give us what? It is always supposed to give us a positive value. So this function will only be valid between negative 2 and positive 2. Please, it will only be valid between negative 2 and positive 2. Okay, so this is negative 2 and positive 2. Meaning that from negative 2 it will be going like this. And then from positive 2 it will also be going like this. This is where the function is going to be valid. So they are going to join somewhere. They form more like a quadratic like that. So you can't have any value down here. You can't have any value down. Okay, you can't. You can try. Get any value greater than a positive 2. Like a 3, put in this function. You are going to find the square root of a negative number. Like 3. 4 minus 3 squared to give you a negative. Is it negative 5? What is the square root of negative 5? It's a complex number. You don't want complex numbers. This is a set of real numbers. So mean that for this function, the domain of this function is from negative 2 to positive 2. And then the range of this function. Now you need to find this value where the functions, this one coming from this direction is meeting with this one coming from the other direction. So that is happening when x is 0. So when x is 0, put 0 here to be square root of 4, meaning that it is a 2 here. Okay, that's a 2. Meaning that for the range, the smallest y value you can have is 0. The highest value of y you can have is a positive 2. And you are including both. So this is the range of this function. You can't have anything below negative 2, you can't have anything, below 0, and you can't have anything above positive 2. Are we okay here? Are we okay? Now, let's say it was x is equal to square root of, let's say, uh, 9 minus x squared and then plus a 4. How does this function go? So equate what is inside to 0 again. Okay, equate what is inside there to 0. You are going to find that 9 minus x squared is equal to 0. Take x squared is going to be positive 9. Square root both sides. X is going to be 3, or x is going to be negative 3. Positive 3 or negative 3. So also put positive 3. Actually, it should first be negative 3 and positive 3. Then get a function itself 9 minus x squared. If you use anything above negative 3, okay, get any number between negative 3 and positive 3, like a 0. That's the simplest you can get. You put here 9 minus 0 squared, it will give you a positive value. If you get anything above 3 to be negative and anything below negative 3 to be also negative, mean that the function is also just valid between negative 3 and positive 3. So for this function, x value is there, y value is there, so you are going to have negative 3 and positive 3. Now notice that it is positive here, that's why the function is going to be going up. But you've also changed the y value, okay? It's now at positive 4. Positive 4 there. Meaning that the function is going to start at 3, positive 4 and negative 3, positive 4. Because it's positive here, meaning that the function is going to be going up. It will be going like this and also coming like this. Okay, so they are going to join somewhere there, and they are going to join when x is 0. So put 0 here. You are going to have square root of 9, which is a 3, plus 4, which is a 7, meaning that at this point that is 7. So the domain of this function is from negative 3 to positive 3, and then the range of this function is from 4 up to 7. You can't have anything. You can't have a y value less than 4 or greater than 7 for this function. So if there was a negative here, things would have changed. Okay, so when there's a negative here, instead of the function going up, what happens? It is going to be going towards negative values of y. Okay, so let me put that. So if there is a negative, to be going towards the negative values of y, so the function would have been going like this, and then this side also it would have been going like that. So this value where they meet, still x is supposed to be 0, so it's going to be negative square root of 9, which is a 3. So that would be negative 3 plus 4. Negative 3 plus 4, that is a positive 1. Actually, it's not even supposed to cross the x-axis because it is coming to cut at positive 1. So meaning, let me uplift this. Let me put 4 here. So it's going to be here and here. So it is coming to cross to have a minimum at 1. So it's going to be coming like this when it reaches here, and then it goes also like that. Meaning that the domain is still from negative 3 to 3, but the range changes. It's going to be from positive 1 up to positive 4. So that is how the function is going to change, and that is how it becomes. Okay, any question? Any question? Let me look at a last example on sketching of radical functions. Y is equal to, let's say, square root of x squared minus 16 plus, let me say plus, I can say minus 1. Okay, like that. So firstly, equate what is inside here to 0. You are going to find that x squared minus 16 is equal to 0. So from there, we're going to find that x squared is equal to positive 16. X is going to give you 4, or x is going to give you negative 4. And then from here now, you have got negative 4 and positive 4. What happens when you get a function x squared minus 16? You put any value smaller than negative 4, for example, negative 5. Put here negative 5 squared is positive 25. Positive 25 minus 16 to give you a positive value. And then also this side it will give you the same, like if you get a 5 squared minus 16 it will be positive, but between it to be negative. For example, is 0. 0 squared minus 16 it will give you a negative value. Mean that this function is going to be valid for values of x on the positive side and also on the negative side. So to sketch this function, x there, then y there. So we have got positive 4, we have got negative 4, and then we have got negative 1. This function is starting at 4 comma negative 1, negative 4 comma negative 1. Remember, it's supposed to be going to the to values of x greater than 4. Okay, so meaning that this function, since it is positive here, to be going up, so it will be going like this, and then on the negative side it's also be going like that. So also this side it will be going like this. So you can actually find the values where it is cutting the y-axis. Okay, where the function is cutting the y-axis, you can find those. And where it's cutting the y-axis, what are the values of x? Actually, it's not cutting the y-axis, but it's cutting the x-axis. So you can find the values where it's cutting the x-axis or the x-intercepts, and that happens when y is 0. Put 0 here. So that will be 0 is equal to square root of x squared minus 16 minus 1. Take 1 the other side. Square root of x squared minus 16 is equal to positive 1. Square both sides to kill the root. So that will be x squared minus 16 is equal to positive 1. Take 16 the other side. X squared is going to be 17. Square root both sides. X is going to be square root of 17, or x is going to be equal to negative square root of 17. Like, it should be positive or negative. So this is going to be square root of 17. This is going to be negative square root of 17. If there was a negative here, if there was a negative, let's say it was negative square root, it would have been going down like this, and then also this side it would have been going down. So that is how it would have changed, because we are going towards negative values of what? Of y. Yes, Martha.
So, but why is this one different? Why is it, why is the okay? Why is the graph kind of different? Because there are two separate graphs here. These other ones were just one.
So they are different because it's a squared function, apart from it being a squared function, x is positive. The other one which I showed was 9 minus x squared. But if I said x squared minus 9, it would have been looking like this one. But 9 minus x squared, they are going to meet somewhere like this. X squared minus 9, they are going to go to opposite directions like that. So when you are starting with the x, they are going to go to opposite directions. When you are starting with the number and then the x, they are going to come and meet somewhere. So meaning that for this function, the domain of this function, the smallest x value you can have, first we have got negative infinity, okay, negative infinity up to what? Up to negative 4. And then you have got now from positive 4 up to positive infinity. That's a domain. And then the range of this function, you just look at a constant, okay? Just look at this constant. That's the one you start at. As long as it's positive here. Remember the one we've sketched is for the positive. This one I just put it there. So it will be from negative 1 up to positive infinity. Like you can see, we're starting from negative 1 to positive infinity. But if there was a negative here, it means that you are going to start from negative infinity, and then the highest value will always be this constant. So if there's no constant, it means the highest value will be 0. Since there's a constant, it will be negative 1. If it's positive, you always start from the constant and then go to positive infinity. That's how you sketch radical functions.